Moritz Wanzenböck, and I work at LINBIT here in Austria. And I'm here to give you a storage deep dive for this. To be clear, if you take a look at the architecture, Cozystack, it's in one of the three kind of founding layers of Cozystack itself. Is the storage layer, and a lot of us actually consume already this storage layer. Of storage is important. So if you want to build a private cloud, you need some kind of cloud storage, because everybody is using purely ephemeral volumes or ephemeral workloads. Maybe if you do, you're lucky. So you have a big choice of different cloud storage, because on Kubernetes front, it's like was already mentioned today. It's like Kubernetes does less by giving you the templates in case of persistent volumes or persistent volume claims, and components actually deal with providing those volumes. And the same applies to snapshots, all other solutions you actually want from your storage, like backups and so on. So you have a lot. You have a lot of, but not all the choices creation. So let's look at what Cozystack needs. So solution for Cozystack, since Cozystack itself wants to be open source, it also needs to be open source. Then to enable the private, you don't want any kind of external dependencies. You know, external NFS you need to set up. No, I don't know, hardware storage solution that you need. No cloud that provides you no EBS, for example. But also the solution should work not just on a focused small setup, but also on different kinds of setup. So you could have an on-prem cloud, but you could also have a lot or big setup that spans multiple data centers, or it is hosted in somewhere. So the storage solution should be able to deal with that. Of course, it needs to be managing, because if you want to provide something as a service, then the storage itself. And last but not least, you also want some performance, because nobody wants to wait hours to just write some bytes to the disk. So this makes me very happy that Cozystack chose Piraeus Data Store. Piraeus Data Store is an open source project which is part of the CNCF sandbox since 2021, and I'm one of the maintainers of it. And I was also already happy to receive some good feedback today that it seems to work surprisingly well for some. For me, it's not that surprising, because we put a lot of work into it. The idea of Piraeus Data Store is bring all the already existing technologies from the Linux storage space into the cloud, and enabling replication, setting up for fault tolerance, letting people create snapshots, apply caching if they need it, and wrap that all up in kind of the cloud way. So dynamic volume provisioning with different configurations, and also very interesting dynamic data scheduling. So basically, if you have a cluster that spans multiple data centers, you want the data to actually be located somewhere near where you actually want to use it, because otherwise you're just sending data over the network around half the globe for no reason. And so for Piraeus, the very bottom of the stack is some actual disks somewhere. This could either be some actual hardware that you attach to your nodes, or it could be something that's provided by the cloud you are using to host your virtual machines that you want to build your private cloud from. And from those disks, we need some kind of volume management to slice them up as we need them. And there's either LVM or specifically with Cozystack and Talos Linux CFS, which works nicely for that because it's already enabled and has some nice features which you can later look at. And on top of that, we can do some or additional block storage features like encryption at rest, deduplication at the block level, configuring some caches, and so on. So one step further out, we are now in our cluster, and we want to protect against node failure. So sometimes a node just blows up or is somehow disconnected. So what we can do with that is we use DRBD, which is a Linux kernel module that does block level replication. So instead of having the copy of your data on just one disk, you basically create a RAID over the network, and so the data is stored on multiple volumes, and then we can do 2 copies, 3 copies, 7 copies. I guess most people will you choose 3 copies, and since this is running in the kernel, it's quite low overhead. There's no long delay on this replication. So it's as fast as it's gonna get. It's as fast as your network. So if you have a 100 gigabit network and your disks are also capable of that speed, we can probably saturate that with the replication. To manage all that, we have LINSTOR, and LINSTOR is kind of a management interface for this whole Linux storage stack. So it has a satellite that runs on each node, and one controller that connects to those satellites and instructs them to create new volumes, create new DRBD configurations, and so on. However, what's important to note here is that this is only used to kind of control plane management. So in the data replication, LINSTOR is actually not involved. It's just sets up the volumes, and then replication happens itself with DRBD and so on. So that's kind of the quick introduction, and now comes the part that is always exciting. It's a live demo. So I have set up a small Cozystack cluster here. As you can see, it's just 3 nodes. And I've already done basically the setup that is part of or that you would do if you choose the Getting Started guide with Cozystack. And that means LINSTOR is also already deployed, or Piraeus, I guess. With Cozystack, it's called LINSTOR, but it's Piraeus in the end. And you see all kinds of pods. And because we want to make it easy for you to configure and manage Piraeus, we also chose the operator pattern, so everything is controlled of the operator. You can have reproducible YAML files that you use to configure storage. So if I take a look at the LINSTOR cluster resource, I can see that it's all available and configured. The 3 satellites, which are the 3 nodes that we have, are all online, and currently we have 162 gigabytes of the 642 gigabytes that we have as available space used, and already 60 volumes. Same applies with the LINSTOR satellite configuration. You can see some more detailed statistics there. And as I was saying, you can configure the storage pools, which is actually one of the first tasks you need to do when you set up Cozystack. And this is done with a LINSTOR satellite configuration, and it's called storage pools, I think. And in this case, it just uses one empty disk that I created for the virtual machines, which is this DEF-VDB, and creates a CFS pool on that. And we can actually see some more details of that from the LINSTOR command line. You can see, okay, we have these storage pools configured, and some more detailed statistics on what is using them. And if you go even deeper, we can connect to one of those satellites and see the set pool status. And if we had a more advanced setup where we would use some kind of local RAIDs or so on, we could have more than one device here. But for this test setup, I just have that one. And actually, we also already have some PVCs in the root tenant. These get automatically set up by Cozystack once you complete your the LINSTOR configuration, because the LINSTOR configuration is always a bit dependent on your environment. Perhaps it's not DEF-VDB in your case, but DEF-SDB or some other device. And now here we see a lot of different volumes, and most of them use this local storage class. And this local storage class is useful if you don't need any kind of replication, for example, because the workload you're using already does its own replication. So for fault tolerance, etcd has these 3 replicas, and they are already running on different nodes, so there is no use to, or there is no need to have extra copies created by the storage layer itself. So we use this local storage class, and you can actually see that local storage class where you can just configure, okay, I want to use this data storage pool, and I just need storage. I don't need anything else. You could, for example, also provide here that you configure here that you need encryption for this volume, then you would have a local encryption of this volume. And yeah, on the other hand, this vlogs generic volume, which is used to store aggregated log data, is using the replicated storage class, because the log collector itself does not do any replication. So we have the replicated storage class, and this tells us that we need 3 copies here with this parameter, and for replication we need DRBD as the replicating layer, basically. And if I take a look again at the PVCs, we can also check that out from the LINSTOR perspective. So resource is basically the volumes. So list volumes, and for example, let us list this PVC here. And we can see that it's currently in use in this middle node, and that the data is replicated live to all the other nodes. And if we compare that to the output of, for example, this PVC, then we see it's there is no replication happening here. It's just a local device on this node. And yeah, so if that node goes offline, you can't access this data anymore. But since the workload itself does its own replication, that is fine. So one thing that Cozystack also already did for us is setting up monitoring, which we can take a look at here. I've already opened the Grafana dashboard. So if you create Cozystack or go through the Cozystack tutorial, you will get also access to this dashboard, and in there you also already find the Piraeus data store dashboard, which also shows you some nice statistics and some statistics on different write rates and read rates, and should there be any errors, they will also show up in here. Yeah. So other things that you can do is create snapshots. We integrate with the Kubernetes Snapshots API. So if you take a look, I have a sample right here. So this is a regular Kubernetes object, and you just tell it snapshot class. This is provided by Cozystack also, and you just tell it which PVC you want to snapshot. And if I apply that, you get a snapshot, which takes some time. So now it's ready to use. We have created a snapshot, and on the LINSTOR side, you can also see that. And this is actually really useful also for things like Velero. If you're not aware, Cozystack has also Velero deployed, so you can configure backup schedules, and Velero will also create snapshots of any volumes that you need to back up, and use those or basically store those snapshots at whatever location you have configured, which is a really nice one, or start into creating backup until the Cozystack backup API gets there. Yeah. And then one thing that perhaps is also of interest, you can use Cozystack to create tenant Kubernetes or create managed Kubernetes clusters. And I actually have already done that in a subtenant. Let's get the Kubernetes, and I've already run that here. So this is my managed Kubernetes created with Cozystack, and automatically in here you also get a storage class, which you can use to create new volumes. And if you create this, it will automatically provision volumes within this managed Kubernetes cluster, which is nice. But they actually get created in the host cluster, and we can see that here, if I go to the right namespace, here the KubeVirt plugin, which is used for this managed Kubernetes, created this PVC and is currently provisioning that. And yeah, that's so your managed Kubernetes cluster automatically also has a storage provider, inherits that basically from the root Kubernetes cluster, and you can select here different storage class. In this case, I have chosen the replicated storage class by default, but you can have more than those two storage classes for different use cases. And finally, one of the newest features which we can take a look at is RWX support, which has been one of the longest standing requests for Piraeus data store. Now we support RWX volumes natively. And let's just take a look at what I have created here. I've created one persistent volume claim with the replicated storage class, and I've set the access mode to read write many, and that's everything you need for your to get started with RWX support. And let's see if that is already done. Oh, stuck in container creating. Sometimes it takes a bit. So now attach the volume and it should soon be running. One thing to notice, these two pods are running from on two different nodes. Or now they are 3. But if I check one of those volumes within the cluster, we can see they have all written their information within this one volume, because it's a read write many, and all of them can use that volume. And with that, I think there's not too much time left. So I'll thank you for your attention, and hope there are some questions that I can answer in the remaining minutes.
Yeah, there are some questions. The question from František. Does performing a LINSTOR PV snapshot rely on use of ZFS underneath, or it is available on LVM2?
So it's available on LVM2. On CFS, it uses CFS snapshot volumes. On LVM, it creates snapshots specifically if you use the thin pool provider for LVM. For thick volumes, we currently do not support snapshots.
And I have personal question. If you create snapshots on replicated volume, which has two different ZFS systems under the hood, how do they sync the point when this snapshot was created?
Yes. So if you use a replicated volume, what happens is that first we issue DRBD suspend IO. So for a short point in time, the IO gets frozen. This also waits until all kind of buffered writes are written out to disk. Then we take a snapshot and then we resume. So the data on all the different systems should be bit by bit the same.
So cool, thank you. Could you also please tell a little bit more about read write many support? Or wait, we have a question from Yo. What about data integrity checks like ZFS scrubs? Is there a LINSTOR level mechanism to protect end user from data rot?
Not right now. We don't configure any kind of scrub timeout. Usually I would tell you to use some systemd timers or something, but for Talos this is not an option. But I'm sure there can be, you can figure out an, I don't know, cron job with Kubernetes that periodically does the ZFS scrubs, CFS scrubs.
Thank you. If you have any questions, we still have 5 minutes left. You can post them into Q&A. We have a question from Konstantin. If disk fails, can another disk on the same node take care of volumes on the failed disk?
Yes, if you configure it with some kind of RAID mechanism. So if you just use the defaults, it is basically kind of just pooling all the volumes together into one big pool. And if you are unlucky and your volume ends up on one of the disks that then fails, then that copy on the node goes bad, basically. We do detect that and would detach if you have replicated it to other nodes. So what would happen is that DRBD would stop writing to the local disk because it returned some, or because it saw some IO errors on the disk and thought, okay, this disk is bad. And on the other hand, if you use some kind of RAID mechanism, then if your RAID level can deal with a disk failure, then we can deal also with the disk failure.
Yeah, I would like to clarify a little bit here. So LINSTOR is fully rely on proven technologies like ZFS and LVM, but not manage them as much. It just cuts the volumes from existing ZFS datasets and LVM pools, and then sets up the DRBD on top of it. So all the tasks, node level failure of the disks, they can be handled by the ZFS itself if it's configured in fault tolerant configuration, let's say RAID 0 or RAID Z, RAID 10, sorry, or RAID Z. Yeah, but the rest things are out of the responsibility of the LINSTOR, I guess. Am I right, Martis?
Yes.
Thank you. One more extending for the previous question is, so alerting from data rot like a failed scrub, would LINSTOR take a notice?
So it would take notice in that it would tell you that this device had some kind of IO error and DRBD detached, and then you later have to tell LINSTOR, please attach again or recreate the volume again and synchronize it from the other replicas after you've after you've put your set pool back in a good state, basically.
Thank you. One more question. How does LINSTOR take advantage of disk nodes for different database workloads? Heavy read or heavy write?
Could you repeat that?
Yeah, sorry, I just mixed with another one. How does LINSTOR take advantage of NVMe drives, or it is agnostic to disk types?
It's basically agnostic to disk types. The advantage we have is that NVMe drives are fast, and if you're not using replication, we basically have, or we can achieve basically the best performance you can get out of the NVMe drive, because it's just the small overhead you pay for this kind of volume management. But if you're not using replication, that's not that big. With replication, oftentimes with HDDs and sometimes with SSDs, actually the local disk is the bottleneck if you have great networking, and we could actually replicate faster than your local disk can write. With NVMe drives, that is very, very unlikely. But I'd like to get my hands on some kind of network that can actually do that. But in general, we are agnostic to the exact disk types.
Thank you. And I guess last question, can I use LINSTOR to configure custom disk nodes for different database workload? That was right now, I guess.
Yeah, no, I think.
Heavy read or heavy write. Yeah, I guess you can just create your storage classes.
Exactly. You can have different storage classes. Those storage classes can also be bound to, or it can effectively be bound to specific nodes by basically disallowing replication or disallowing replication off of those custom disk nodes. And you don't need to apply the storage pool configuration to every node in the cluster. You can just use a subset of those, and then you have, I don't know, three nodes that actually host all the storage, and the other ones are just workers that can consume the storage over the network.
Well, thank you. I would like then put a short announce since the last release, I guess, Piraeus support NFS as read-write many storage. Am I right? That was last release, I guess.
That was last release, yes.
Yeah, we already integrated in Cozystack, and I think in a while that will be available also for tenant Kubernetes clusters. Many thanks to Piraeus maintainers for implementing this feature. I think that was most wanted for a long period of time.
Glad it's of use. So thank you.